When you picture a gold strike in the movies, it usually looks like this: large, glittering nuggets practically jumping out of the rock face. But modern industrial mining rarely looks like Hollywood. As this scale visualization shows, most active mines today rely on low-grade ore. The operators hunt for a microscopic 1 to 3 grams of gold, scattered deep inside a massive 1-ton boulder. That extreme ratio creates an immediate economic wall. Running a full ton of solid rock through a traditional, energy-guzzling crushing mill to extract that single gram costs more in electricity and mechanical wear than the gold is actually worth. By the 1980s, the industry reached the limits of brute force mechanical excavation. To keep producing, engineers needed a way to pull metal out of the earth without the massive overhead of moving and crushing tons of rock. The solution they developed is called gold cyanidation heap leaching. Rather than grinding the rock into powder, they extract the gold using the same basic mechanics as brewing a massive cup of drip coffee. Solving this economic puzzle unlocked millions of tons of previously worthless earth, expanding the global supply of precious metals through efficiency rather than discovery. The first requirement for this massive brewing process is creating surface area. The raw ore is fractured into gravel, roughly 20 millimeters in size, allowing liquids to penetrate the rock. But crushing rock creates a severe complication: dust and clay. When wet, these ultra-fine particles turn to dense mud, completely blocking liquid from flowing downward. To fix this, engineers use a process called granulation. They spin the crushed ore in a drum with water and a binder, usually cement or lime, forcing the dust to bind to the larger coarse chunks. This creates highly porous, permeable pebbles. With the ore prepared, the site is constructed. Before a single rock is placed, the crew lays down a thick, leak-proof bottom mat made of asphalt or heavy plastic. This layer captures the dissolved gold and prevents chemicals from reaching the earth. The granulated ore is then carefully stacked onto the mat. The piling method is strictly controlled to maintain that uniform permeability, ensuring the fluid flows evenly throughout the entire structure. A short-term heap might stand just 3 to 6 meters high and process material over a few weeks, but long-term operations are colossal, holding millions of tons of ore in tiered structures that leach for several years. The resulting pile functions as a freestanding chemical reactor, meticulously designed for uniform fluid flow. Once the pile is built, the extraction begins. The operators mix a calibrated working solution, a blend of water and cyanide designed to specifically seek out and bind to microscopic gold. This solution is misted over the top of the heap through a network of sprinklers at a controlled rate, usually 0.1 to 0.4 liters per square meter per minute. If the spray is too heavy, the heap's internal structure will wash out. As the mist settles, it trickles down through the negative space between the granulated pebbles. Deep inside the pile, the invisible chemistry takes over. The cyanide reacts with the precious metals, pulling them out of the rock and dissolving the solid gold into a liquid state. This liquid, now called the pregnant solution, percolates down until it hits the impermeable bottom mat. It runs along the slope, channels into drainage grooves, and flows out of the heap for collection. From there, the pregnant solution is pumped into a processing facility, where it runs through activated carbon or zinc powder. These materials strip the gold straight back out of the liquid. The process relies on gravity and chemical affinity to extract the metal, performing the work of massive industrial mills with almost zero moving parts. If we look at this chart showing overall extraction efficiency, we see the physical trade-off of the method. The fluid dynamics are never perfect, meaning heap leaching leaves roughly 20 to 40% of the gold permanently trapped in the rock. But the math remains favorable. Because the system bypasses the immense electrical and mechanical costs of milling the ore, the operational overhead drops significantly. It is more profitable to capture 60% of the gold cheaply than to capture 90% of it expensively. The system is also highly adaptable. These permanent unloading yards can be draped directly over a mountainside, perfectly matching the local topography, and the final output is the same. Once the pregnant solution is processed and smelted, the resulting solid bullion is indistinguishable from metal pulled from the highest grade veins on Earth. Heap leaching proved that industrial success comes from building systems efficient enough to extract wealth from the material that previous generations walked over.